Today you'll be looking at binomial expansion using Pascal's triangle. Okay, so to quickly expand binomials, there's an easy way to remember the coefficients. Remember, we can use Pascal's triangle. It is named for a French mathematician. So notice that the top row here, this represents a degree of 0. Okay, that's highlighter. Degree of 0, because anything to the 0 power is just 1. If we look at something else about Pascal's triangle, we notice that the first number in each row is 1, and so is the last number. And all of the numbers are formed by adding the two previous above it. So in other words, if I were to add this 1 and this 1 together, we get the 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Okay, and now we're going to practice expanding some binomials. If we look at our first example, it says we're going to expand x minus 3 to the 4th power. And notice it says we're going to draw 5 blanks. The reason why is if we go to our row that has 1, then 4, that tells me the row of Pascal's triangle I'm going to be. The second number into the triangle from the left is the degree number. And notice we have 1, 2, 3, 4, 5 terms. So we're going to draw 5 blank spaces. And in those spaces, we're going to place the first term in the binomial, which is an x. And then notice we're going to place the second term in the negative 3. Now, if I have a negative, I have to make sure we put our parentheses. And then notice we're going to do exponents from left to right, starting at our degree 4 and count backwards. Then we'll do our exponents from right to left, starting with a negative 3. And then the last thing we'll do is we'll put in the coefficients from Pascal's triangle, which would be the same numbers had we used NCR or combinations or the binomial formula. Okay, and then all that's left for us to do is to clean it up. So we know negative 3 to the 0 power is 1 times 1 is just going to give us x to the 4th. In the next one, we know 4 times negative 3 to the 1st power is negative 12, and we'll have x cubed. Negative 3 squared is 9 times 6 is 54x squared. Negative 3 cubed is negative 27 times 4 is negative 108x, and then negative 3 to the 4th power is plus 81. And then that's it. Take a minute and try this example you tried. Okay, so hopefully for this one you found x to the 4th plus 16x to the 3rd plus 96x squared plus 256x plus 256. If we look at our next example, we're going to do the same thing but in a vertical fashion. So notice we have a 6. So when we do our Pascal's triangle, we want to continue expanding it until we get a 6 inside the exterior ones. Okay, and it looks like we're going to draw 7 blanks. And we're going to place a 2x in parentheses in each blank to start with. And then notice we're going to place the second term a positive 3. And from there, we'll start with our exponents. This time we'll start over the 2x, and we will work from top to bottom. I started at the wrong numbers. Hold on. 6, because that's our degree. Hello. And then we will come back around from the bottom of 3 and work our way up by counting backwards. And then the last thing to do is to insert the coefficients of Pascal's triangle. All that's left for us to do is to clean it up and write our final answer. So we know 2 to the 6th power times 3 to the 0 power for this guy here would be our 32x to the 6th. We know that 2 to the 5th power is 32 times 6 times 3 is 576, x to the 5th. For the next one, 2x to the 4th would be 16 times 3 squared, which is 9, times 15 is 2,160, x to the 4th. For 2 to the 3rd, that would be 8, times 3 to the 3rd would be 27, times 20 is 4,320. Then we would go to 2 squared times 3 to the 4th times 15, or 4,860 x squared. And then 2 to the 1st times 3 to the 5th times 6, 2,916. And then 3 to the 6th power is 729. And that's it. So if we look at our next type of question, it says we're going to find the first 3 terms of this expansion, and we're going to use binomial theorem, and we're going to use Pascal's triangle. So binomial theorem, obviously we're going to have our 3 blanks, and because our degree is 6, remember we'll start off with 6 choose 0, and we will have 2x to the 6th times negative 5y to the 0. And then our second term, we'll do 6 choose 1, 2x to the 5th times negative 5y to the 4th, our first, sorry. And then we'll have 6 choose 2, 2x to the 4th, negative 5y to the 2nd. And then we just use a calculator. Okay, 2 to the 6th we know is 64, 6 choose 0 is 1, and negative 5y to the 0 power is 1. So here we would have 64x to the 6th. 6 choose 1 is 6, times 2 to the 5th would be 32, times the negative 5 would be negative 960, x to the 5th y, and it's negative because of this guy here. 6 choose 2 times 2 to the 4th, which is 16, times negative 5 to the 2nd is 25, is 6,000, x to the 4th y squared. Now, to do this with Pascal's triangle, it is very similar. We would start off with our blanks, and we would start off with our 2x and our negative 5y. Remember, exponents start on the first number in the binomial, so over the 2x, 6, 5, and 4. And remember, the sum of the powers have to equal that degree. So for the y's, the top negative 5y would be 0, 6 plus 0 is 6. The next one would be 1 and then 2. And then we have to insert from Pascal's triangle the coefficients of 1, 6, and 15. And then we type it into the calculator. 64x to the 6th minus 960x to the 5th y plus 6,000 x to the 4th y squared. And notice that our solutions are the same. So when you do this problem, I do not care if you use the binomial theorem or you use Pascal's triangle. Now I would like you to take a minute or two and try this example you try. And hopefully you found this one to be 2,187 x to the 7th minus 20,412 x to the 6th. And hopefully you found this one to be 4,330,260 x to the 9th y cubed. You are officially ready to try some practice.